This video is about the fundamental theorem of calculus part 2, and the condition is if f little f here is continuous, so f is continuous on AB, then the definite integral from a to b of f of x dx is equal to capital F of b minus capital F of a. Capital F here is an antiderivative of little f. So we're going to use the fundamental theorem of calculus part 2 to find some antiderivatives. So example 1. Find the integral from -3 to 1 of x squared plus 1 dx. Now, to use the FTC, the fundamental theorem of calculus part 2, the first thing to do is to find an antiderivative of this function. So antiderivative. And an antiderivative of this function is x cubed over 3 plus x. Normally we should write plus c, but one thing that you should remember when dealing with the fundamental theorem of calculus part 2 is you don't need to have the constant c anymore. So we can erase the constant c. So just find an antiderivative, forget about the constant c. And then what do you do with the antiderivative? For the notations, let me get this out of the way. You draw a vertical line. So after you find the antiderivative, you draw a vertical line. You write the lower limit, -3, and the upper limit, 1. But what does that mean? It just means that you're going to plug the upper limit first, and then you subtract the number you get from plugging in the lower limit. The upper limit here is 1, so when you plug 1 into this antiderivative, you get 1 cubed over 3 plus 1. And then minus is always minus. If you look at the FTC part 2, you see the minus sign here. So it's always minus. So that's why it's a good habit to write 2 sets of giant parentheses separated by the negative sign. Now we're going to plug in the lower limit. So -3 cubed divided by 3 plus -3. Now we just have to compute this expression here, and you should get 40 over 3. So at the end of the day, you should get a number. Let's go over another example. So example 2. Let's say you want to compute the integral from 1 to 10, 1 over x dx. First thing you do, you find an antiderivative of this function, and an antiderivative of 1 over x is natural log of absolute value of x. Once we have that, we draw the vertical line, the lower limit, and the upper limit. What does that mean? 2 giant set of parentheses separated by the negative sign, and then that gives you natural log. You plug in the upper limit first, natural log of absolute value of 10, and then you plug in the lower limit, natural log of absolute value of 1. If you want to simplify more, you can you will notice that natural log of 1 is 0, so you're just left with natural log of 10. Let's go over another example. Let me erase this one. So example 3, let's find the the integral from 1 to 4 of 1 over square root of x dx. So what is it equal to? We need to find an antiderivative of this function, so we have to rewrite it. So when we rewrite, you have 1 to 4 x to which power? Negative 1/2 dx. So when you're rewriting this expression, that's what you get. So this is equal to 1 to 4. Let me just erase. We can already find an antiderivative of that function. So this is x negative 1/2 plus 1 over negative 1/2 plus 1. And we draw the vertical bar from 1 to 4. But let's first of all simplify this expression. So this is equal to x to the 1/2 divided by 1/2 from 1 to 4, vertical bar. So this is 2 square root of x, the vertical bar from 1 to 4. And at this point, what do? We draw two sets of giant parentheses separated by negative sign. The first one, we plug the upper limit, so we're going to plug 4. We get 2 square root of 4, and the second one, we plug in the lower limit, which is 1. So 2 square root of 4, that's 2 times 2, that's 4, minus 2. So the answer is 2. Now, for more practice, go ahead and work out these problems here, evaluate the integrals, and I've given you the answers so that you can check your work as well. And for number 2, you have a hint. The first thing to do is to rewrite this function before you find the antiderivative. So one thing that we have to remember is we do not worry about the constant when we have these limits on an integrals, these numbers, upper and lower limits. We do not worry about c anymore. And you should be fine.